Good afternoon. Myself Dr. Ruchi Gupta. Today we will discuss the topic software requirement specification, that is one step of requirement engineering phase, that is requirement analysis. So as I have already discussed in my previous lecture that requirement engineering is having 4 steps: requirement elicitation, requirement analysis, requirement review, and then final requirement verification. So, requirement analysis is the second step of requirement engineering that is used for preparing the SRS. So, requirement analysis phase is used to refine and scrutinize the requirement which have already collected with the previous step, that is a requirement elicitation phase, and we have to collect the clear requirements and we have to destroy the unclear or missing requirements in this phase. So, we can say that we have to scrutinize or refine the requirement with the help of requirement analysis phase. So, these are the various steps of these phase. One is, first of all, we have to draw the context diagram, then we have to develop the prototype, then model the requirement, finally we have to finalize the requirements. So, first of all, we have to draw the context diagram of the requirement which we have taken from the previous steps. So, what is a context diagram? It is a simple model that defines the boundaries and interface of the proposed system with some external world. So, we can say that in the context diagram, we have to represent the whole system with the help of a single circle, and all the inputs are to be taken by the system. Then system will process, and after that it will give some results. So, we have to show the whole system with a single circle in a context level diagram. So, here we have taken the example of a student management system. So, in this one actor, that is a data entry operator, another one is an admin, next one is a teacher or a student. So, data entry operator is responsible for maintaining the student entry, and admin is responsible for maintaining the user account details, and teacher is responsible for maintaining or entering the marks entry of the students. And students will just put the username and password, and they are viewing the results. So, after when all the users will put their values, put their input into the system, then after that the student result management system will give some result. We have to get some results from this system. So, it will generate the records of the students, and it will use for generating the marks details of the students. Now, the next step is developing a prototype. Now, prototype is basically helps the clients to visualize the proposed system. As I have already discussed in the prototype model, is that basically the prototype model, it is a visualization of the actual product, and it is visualize the proposed system and increase the understanding of the requirement. So, prototype may help the parties to take final decision. Now, the third step of requirement analysis is model the requirement. So, in this process, usually we have consist of various graphical methods of functions, data entities, external entities, and their relationship between them. And we have used various modeling method, or we can say various UML diagrams we have to generate for model the requirements. So, these are some of them, these are some of example of these modeling. One is the activity diagram, data flow diagram, data dictionary, and ER diagram. So, first of all, we have discussed about the activity diagram. So, activity diagram, they are basically present a series of actions of flow or flow of control in the system. It is, we can say it just like a flow chart or data flow diagram. So activities diagram offer use in the business modeling, and it is one of the example of UML approach, a unified modified language. Activities models can be sequential or concurrent. So why there is a need of activity diagrams? So we have to use these activity diagrams for analyzing the use case which we have already created in the requirement analysis phase, and understanding the workflow across many use case, and dealing with multi-threaded applications. So these are some notations which we have used at the time of creating the activity diagrams of the project. So first of all, we will take a start point or the initial state. Initial state or start point will be represented by this dotted symbol with arrow. So it is a small fixed circle followed by an arrow that represent the initial state actions or the start point of the diagram. Then we have to use a activity. We have to represent the activity with this oval circle, and it represent an action state, and it represent the non-interruptible actions of objects. Now we have to represent the arrow for action flow. This action flow, also called edges and paths, that illustrate the transition from one state to another state. So they are usually drawn with some arrow line. It is drawn with the arrow line. Now object flow, it refers to the creation, modification of the objects and entities, and we have to just represent this object flow with the help of this diagram. So one is the activity, and this is our class or object. So we have to show the object flow information from activity to class with this notation. Now the next symbol is a decision symbol or diamond symbol. It is represented by the diamond symbol, and it shows the alternate path. So when an activity requires a decision prior to moving on the next activity, it will add diamond symbol within two different activities. Now this symbol, it represents the guard. It is a guard symbol. So in UML, guard are the statements that are written next to the decision diamond. So if we have to go for the decision, then decision, it may be yes or no. So it is a guard symbol. Either we have to go for yes direction or for no. Now these are two symbols. One is used for the fork symbol, another one is a join symbol, and both are the synchronization notations. So first one is a fork. Fork node is used to split a single incoming flow into multiple concurrent flows. Means if we have to go from one activity to multiple activities, then we have to use a fork symbol. And if multiple activities, with the help of multiple activities, and we have to go for a single activity, then we use a join symbol. So join node multiple concurrent flow back into a single outgoing flow, and fork and join both used together are often referred to as a synchronization. So when we have to combine both fork and join symbols, then it become a synchronization. This is a swim lane notations. Swim lanes group related activities into a one column. It will use to group two different activities into a one column, that is swim lane. And this is an example of library management system. This is an activity diagram of library management system. So we have to start with the start point. Then we will take first activity, that is inquiry about books. Then go for the second activity, check availability of book. Book is available or not. Is it available or not? Then we have to use a diamond symbol. If it is available, then next activity will be executed, that is validate the member. If it is not available, then book not available, and we will go on to the end state. Now we have to check the book availability. If book is available, then we will check the member, that member is a valid member or not. If the member is valid, then we have to issue the books. to that candidate, and we also check that the maximum quota exceed. If it is yes, then book will be not issued, and if it not, then we will issue the book, add member book issue detail and update the book status, and then finally we'll go to the AND state. Similarly, if the member is not valid, then book will not issue to a member, and then we'll go for the book issue again. So this is a activity diagram for library management system. Similarly, you can design the activity diagram of any problem. This is another example of a hospital management system. This is a view reception. This is for registration process. Another one is activity diagram for ward allocation. This is another diagram for performing the test. This is another activity diagram for the treatment and operations. This is another diagram for discharging of the patient. So we can say we have to create multiple activity diagrams for a particular project or particular problem, and then finally we have to combine all these diagrams. Now another data modeling example is a data flow diagram. So as I have already discussed the context flow diagram in my previous slides, this is a zero level DFD or zero level data flow diagram. So data flow diagram, it is a graphical or visual representation of data flow through business process. So basically the purpose of this data flow diagram is the visualization of the flow of data and transformation between different processes. So these diagrams show the route that data takes flow within the system and show the transformation of storage as well as the data by the process. So they also show the transfer of data between different entities as well as different data storage media. And DFD does not show the elements which control the data. These are some symbols of data flow diagram which we have used at the creation of DFD. It is a data flow. This is the symbol of connecting process. The circle will represent the process. It performs some transformation of its input data to output data. Rectangle, this is a symbol of source or sink. A source of system output, sink of system output, and this symbol will represent the data store. So a repository of the data, the overhead indicate the net input and net output to store. Now we come on labeling. As I have already done zero level DFD or context level DFD. So other different type of DFDs also we have to generate, that is level 1 DFD. Also we have to generate the level 1 DFDs. This will provide a detailed view of requirement and flow of data from one level to another. So this is the use case diagram for level 1 DFD. This is the use case diagram for result management system, and this is the zero level DFD for the result management system or a context level diagram. As I have already discussed this diagram in detail, and this is the one level diagram for one level DFD for the result management system. So in the one level DFD, we have to describe more as compared to the context level DFD. And there is also one difference in the zero level DFD or one level DFD is that in the one level DFD, we also show the data storage which we have not show in the context level DFD. So this is our context one level DFD of result management system. So first of all, the subject information, it will store into the subject database. This is a student detail, student management, the information will stored into the student management. This is our marketing marks information management. This is our login process. User will validate, will give the user ID and password, validate the user, and it will store into the user information storage. This process is related to the reports generation regarding the marks or result. It will generate by the administrator. So, this is whole purpose of show that how the information is flow from one process to another process. So, this is one level DFD. This is again level 2 DFD. Again, we have to describe very deeply. So, in that case, again we have to show the flow of information between different process. So, here we have to show the flow of login process. This is for generate report, display information. So, again we have to describe further. Again we have to show the flow of information in depth. So, these are the different 2-level DFD for the marks information system. Now, we come on the data dictionary. So, basically the data dictionary, it is simply a repository to store the information about all the data items which are defined in the DFD. So, the data items which we have defined in the data flow diagrams, these data items are to be stored in the data dictionary. So, it includes name of data item, description, purpose, range of values, data flow, data structure definition. So, this is one of the example of like phone number, phone management system. This is DFD, this is 0-level DFD of this phone system, and we have to store the information of the data items in this data dictionary, and which included in the data flow diagram, that is in DFD. So, name, aliases, where and how we have to use, description about the phone numbers, format, etc. This is the these are the notations of data dictionaries. X is equal to A plus B means X consists of data elements A and B. X is equal to A divided B means X consists of either A or B. X is equal to A means X consists of an optional data elements A. X is equal to Y is equal means X consists of Y or more occurrence, and X is equal to AZ means X consists of Z or fewer occurrence of A. So, this is example of data dictionary. Now, we come on information modeling. So, in software engineering, it is a representation of concept, relationship, rules and operations that specify the data semantics for chosen domain of disclosure. It can provide some shareable, stable and organized structure of information. So, in the data modeling, we have to represent the ER diagram, that is entity relationship diagram. It is a detailed logical description of data that is organized into 3 main constructs. One is entity, their relationship and attributes. So, entities, these are the fundamental things about which the data may be maintained, and each entity has its own identity. Entity type is a description of all the entities which are common definition and common relationship and attributes apply. This is then a relationship. It is a reason of associating two entities type. It may be a binary relation or ternary relation. So, one example of this entity relationships diagram is shown here. Customer is insured by the policy and it is managed by the made against policy claim. So, this is a ER diagram. There are various type of degree of relationship in ER diagram. Unary, one to one, one to many, many to many. This is binary relationship. This is ternary relationship. These are some notations, attributes, and this is the whole example of a result management system. This is the ER diagram example for the result management system. Now, we come on the decision table. So, decision table, it is a table for the various conditions and their corresponding actions. It is a logical structure with all possible combinations of conditions and their resulting actions. So basically we have three parts of this decision table. One is the heading part, condition, then action, and correspondingly action is to be taken as per their rules. So it is a metric representation of logic of conditions. It specifies the possible condition and their resulting actions, and the best use for complicated decision labels. So rule number, condition entries and action entries. So it consists of basically three parts: condition, action and rule. So conditions show the various possible conditions, actions show the result we get from the conditions, and rules specify the actions that are to be followed for the given set of conditions. Here we will take one example for decision table. So suppose if we have to take the decision table for the payroll system. So in the payroll system, suppose we have two type of employee. One is a permanent employee and another category is a ad hoc based employee, and the working hours for each employee is 40 hours. So it may be increase or decreases. So we have to take two conditions. One is the employee type category and second one is a working hours. And these are the rules. Rules are two rules for the permanent. One is a permanent employee, another one is a ad hoc based employee, and these are the working hours. So on the basis of these rules and condition, we have to take some decision. Pay based salary, calculate early wages, calculate overtime and produce absence report. So suppose if the employee is a permanent employee and the working hours is less than 40, then we have to calculate their salary on the pay based salary basis. Now if your employee is a ad hoc employee and the working hours less than 40, then we have to calculate their early wages and absent report. Similarly, if permanent employee, working hour 40, then pay based salary. If ad hoc employee 40 hours, then we have to calculate the salary early wages. If permanent employee less than 40 hours work, then calculate base salary. If employee is ad hoc, it work greater than 40 hours, then we have to calculate the early wages as well as the overtime. We have to calculate it. So this is a process of making some decision on the basis of their conditions and rules. We have to take some action. So thank you very much.